Miss Bonnie here. Another month has passed and we're back again with our STEM Junior experiments and even working on some of those bodily things that we're finding are unusual based on our human body and the bones and so forth. So we have a number of experiments today, which I'm excited about. And we're going to start with one. Now I am using test tubes pretty much, mainly because I don't have a lot of the liquids that I'm going to talk to you about. So I wanted something narrow that I could put it in. And inside, as you can hear, I have marbles. And what I did was I took 4 marbles that we have, and they are exactly the same size. Okay? They are exactly the same size, as you can see right here. And what we're going to do here is really, it's going to be a marble race. Because I only have 2 hands, we're going to do this in 2 separate ones. It's all about liquids not being equal. Now, when I talk sometimes about liquids, some of them seem very thin, like this vinegar, and like water, okay? Very, very thin. So that is actually considered low viscosity. And when I use the term viscosity, I also think of density. So it's not very thick, okay? It's very thin. And what we're going to prove here is basically the length of time it takes the marble to go down to the bottom of each one of these test tubes. And let's see what has a low viscosity versus a high viscosity. And what I have here is just so, again, if you were to do this at home, try a couple of different items. I've got honey here. Now this is a dark color of honey, so it's going to be hard to see the marble as it comes down. But take a look and see. I also have some oil, like cooking oil. And I also found some baby oil that we've used for other programs as well. So I'm going to start with 2 of them. And I'm going to start with, I think I'm going to start with the vinegar. And I'm going to put vinegar, again, you don't need to use a test tube, you can use a glass. Just make sure your glasses are all about the same size. So I'm filling it pretty much full. And try to get it the same amount of liquid for each one that you're going to test, okay? So I think I'm going to try the Wesson oil first. And again, it doesn't have to be Wesson oil, it can be any oil, cooking oil at all. You can even see the way it pours. It's a little bit thicker than the vinegar, right? So I'm going to make it, whoops, that's not quite even, so I'm going to get rid of some of it, put it back in. All right, it's still a little bit too much. Let's try it now. That looks about equal. Now I'm going to set up the other 2 as well so that we will have them. The first one is actually going to be water. I'm going to try it with water. Just water. Fill your glass. If you're using a glass, fill your glass up. Okay. And I think I'm going to try the honey. Now again, remember that the honey is dark in color, so we have to look very, very closely when we go to drop the marble in. So again, we had vinegar in this one. We had Wesson oil, any kind of cooking oil. We put water in here, And we put honey in there. It looks like molasses too. So now I'm going to start at this end. And I've got my 2 marbles that are exactly the same size. They weigh pretty much the same size. And I have to drop them at exactly the same time. So we're going to see which one goes down faster than the other. All set? Here we go. This one. Not by a lot, but it did go down a lot faster than the other. So what that truly means is the vinegar, and you can see the vinegar, I mean, look at how thin that is compared to the oil, which is here. So it took a little longer for the marble to get down in the oil than it did in the vinegar. Which reminds me, it's very difficult to mix vinegar and oil together. Some people like that in their salads. It doesn't stay mixed very well, and you have to continually shake it to get it to work. So now I've got this really gooey honey, and I got water. We all probably realize that the water is going to go down a lot faster. But let's even see how long it takes for it to get through the honey. So here we go. We're going to do them both at the same time. That honey, it's like trying to see where it actually is at this point.
You could see it pretty well when you had it before, because we could see the yellow stripe.
Like it had to get through the clump, which it did, starting to go down more. What that means is it is it has a high viscosity, which means it's going to pour slower. Anything that drops into it, it's going to be that much slower than the other areas. So the greater the viscosity, the slower the marble, which is that. The next one would be this, which is the oil. Not by much. I mean, that wasn't too much different than actually the water is compared to the vinegar. So those are the 2 that would be the higher viscosity. And again, that's how you can tell how things are going to pour, what's heavier, what you could put in it, and possibly it will flow. Those are all things that you can think about. When you do this experiment, it's okay to try anything. And if you have siblings in the house, you might want to have different people. You do too, and whoever is next to you, do the other 2 at exactly the same time and see which one has the higher viscosity. So that's how this particular one works. Now, what I wanted to do, I'm going to kind of get my hands off of that gooey honey. All right, so what I wanted to do was talk to you a little bit about matter and energy, okay? Albert Einstein, who was very, very famous, not only was he a genius, but an inventor and so forth, he believed that matter can transform itself into energy, and energy can then also transform itself back. Matter can transform, Matter can transform into energy, and vice versa. Energy can transform into matter. So, very simply, if you make facial expressions, I'm going to make a facial expression, I'm going to make a frown, and I'm going to make a smile. My first one is a frown. A smile is, think about when you do that, what's using more energy? I'm finding my frown needs a lot more energy to make that face than it would if I smiled. Smile is very much more positive. And I see Meg over there, she's trying to do the same thing. And did you feel that it was the frown?
Yeah, my frown took up was more work.
So your energy is what makes things happen. The more energy you use, the more something is going to occur. Now, I'm gonna do another one that's kind of silly. And it's like last month, we actually stood against the wall and we tried some of the things with the wall. And I'm kind of moving off to the side, and eventually I'm going to see if Miss Meg can try this too. What it's really about is we talk about your body, your system, your body, how you're dealing with things, whether it's your immune system, are your muscles flexible, how are your bones. That's all very important to maintain them and to be very strong. And what happens, the older you get, the less muscle that you have. Your muscles are not as strong as they were when you were younger. So there are bendability. This experiment is really about bendability. And there are 4 basic elements of your physical fitness. Now, I'm sure a lot of you run around, a lot of you maybe do some exercises, but one of the most important things is really your flexibility. And that's an indication, okay, that helps you to understand how good in shape am I, okay? And again, remember, my age compared to when I have Miss Meg come up and try this, hopefully she'll be able to do it too. So I'm gonna actually sit on the ground, okay? I can sit on the ground easily. I can't get up as easily because of my age. But, okay, I'm gonna sit on the ground. Here I go. Here I am sitting on the ground. My legs are in front of me, okay? And what we're gonna do is we're going to try to touch the ground with our toes, even though your legs are straight out. So how it works is you're actually going to turn, if I can find this, I'm gonna sit here like this, and I wanna see if I can get, without bending my knee, my foot completely to the side, hitting the ground, okay? That one I can do pretty well. That one is a little bit more difficult. And remember, you're not raising your knees. You're just going like this. Can you touch your toe to the ground, okay? Now you can't see my actual toes, you can only see my shoes, but I have to tell you, my big toe is not really reaching the ground, okay? But that's the flexibility that you have or you don't have. Now, the other one is really, I'm gonna get on my knees, okay? And as I get on my knees, what I'm going to do is I'm going to lean back. How far, and I can't probably even do it initially, but you have to have your back straight, just like I'm trying to do right now. And if your back is straight, try to go backwards as straight as you can. How far can you go back? Again, that's all about your muscles and the flexibility in your muscles. Yeah, so Miss Meg is now going to try sitting straight up and move each foot separately and try to touch the ground with it without lifting her knee. Does it feel like your toe is actually hitting, or is it just your shoe?
My toes on this side can hit.
Yeah.
Kind of get it.
So that's a fun exercise to try, because your best bet is probably to try them without your shoes on, and that way you can really see if your toes are touching where it belongs.
I can go inside.
Yeah, I can too. So that just kind of shows how flexible your bones and your muscles, mostly your muscles, but your bone has to be able to go move at the same time. So try that a few times and see if that works. Miss Meg is now going to try the one kneeling with her straight back, and now try to lean back as much as you can with a straight back. She's good. Wait a minute, let me get, I gotta move. All right, let's try that again. There she goes, she's straight back. She can go quite a ways before she needs her hands. Again, she can do it a lot better than I can because she's a lot younger. So this experiment is called the lemon volcano, which I'm sure everybody loves to see things explode. So we're gonna try it. Again, this is something that I did not necessarily try in advance, so we're going to see if it works, okay? So here is what we're gonna do. We actually need a lemon. We need some extra lemon juice. We need baking soda. and a popsicle stick, okay? The other thing is, and this is the adult in your house, because they are going to have to make a couple of cuts for you in the lemon, okay? And this is all about acid, baking soda to lemon, and it combines the citric acid that's in the lemon with the bicarbonate, which happens to be this, okay? And it causes gas, okay, carbon dioxide, CO2. That's the chemical reaction when you take an acid and you take a base. So we're gonna try it. And the first thing you wanna do, the adult do, is cut a little slice off the bottom. Do not go into the lemon, just cut off the skin so that it lays flat, just like that. Then they need to actually cut a hole in the lemon. And I want to get those seeds out. Cut a hole in the lemon and then cut around it so all of the peel that's in there kind of loosens up and becomes juice, okay? And then what we're going to do, we made a hole in the top. One of the other things you could do before you start cutting into it, roll it, because that'll get the juice rolling too. I could put it in a tray because I don't know how messy it is really going to get. You scrape the sides, you've got juice in there. Now what we can do is we can add dishwashing liquid, which will give it some color. So I will use a little bit of that. It's only a few drops. All right, I'm gonna just put a couple of drops. All right, and now I'm gonna take a teaspoon of my baking soda. It's always a good idea, if it's an open one, that you tape it or you do something to it, okay? And that way it doesn't come out all over the place. Okay, so now I'm gonna put the teaspoon in. Let's see what happens. See it foaming? You see it foaming up? All right, so depending if you want, you could add more lemon juice to it. If you add more lemon juice, what will happen with the lemon juice? Whoop, there you go, it's foaming. You could add more baking soda. Now this is not a huge lemon, so you know, how much is it gonna do because of the inside? Let's see. There you go. All I did was take the spoon, push the spoon in further, and you could see it foaming up. Now, if you had food coloring, see it coming out? Food coloring to it, you'd have some pretty colored volcanoes. And you could, again, use a little bit more lemon, use a little bit more baking soda, and you could see how it foams up. And you can actually do this for a long period of time if you keep poking the lemon, okay? See it foaming up again? Now the fun thing you might want to do is if you had more than one lemon and you have a sibling or a friend over, have two of them and see which one starts to flow more or longer or whatever, and it's sort of like a race. So that's how this works with the lemon. I'll bet it would work with just about any citric acid like grapefruit, a big grapefruit. That would be cool, using like a half, because if this doesn't work in the respect of cutting this and somehow it opens up, you're going to get a lot of your volcano down in the tray and not up over the lemon. So if you wanted to, if you had a grapefruit, cut it in half and just put half of it up like this, and then use your stick to make sure you've moved all that liquid around, and try it in the grapefruit. And I'll bet you're going to have a much bigger volcano even with that. Again, that creates a gas that's carbon dioxide. That's our last experiment for today. I hope you enjoyed it. Please let us know how it comes out for you, any or all of these, and we'll see you next month. Bye.